Good morning, everyone, and thank you very much for joining us for today's webinar, Carbon and Net Zero in Low-Rise Residential Sector. My name is Felix, and I'm from the Continuing Education Department here at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from today. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. We highly encourage engagement through our Q&A window. Feel free to submit any questions you may have for our speakers. These will be addressed in the designated question and answer period at the end of the presentation. Kindly note, the chat function will be deactivated following this introduction. For those seeking continuing education learning hours, please note that attendance is important. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please allow up to a few weeks for the processing and reporting of these hours. And lastly, please note that the presenters do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. But now, I'm excited to introduce you to our speakers for today's session. Please welcome Joel Anderson, Paul Dowsett, Carolyn Moss, Duncan Patterson, Brad Tapson, and Kim Marie Degenkolb. Kim Marie is a project manager at Weather Building Technologies with a background in building science and architectural design. Her building science research focuses on operational and embodied carbon estimating and critical carbon life cycle analysis. Kim's goal is to continue exploring new building technologies and tools that improve the accuracy of carbon accounting and contribute to a resilient future. Kim, I'm passing it over to you.
Thanks, Felix. And hi, everyone. Thank you for joining. As you've noticed, there are 6 of us on here. So we're going to introduce the rest of the group in a bit. But we are all part of NZAN, which is a Net Zero Architects Network. The way we kind of formed, we were founded in 2021. The way we formed was basically all of us were kind of doing our own research, having our own findings when it comes to carbon accounting and net zero strategies. And we didn't really have anyone to share them with. So we all kind of duplicated the work, did it all in our own little offices. So we decided, why not join and share the knowledge with each other as well as other industries. So we meet once a month and we go through case studies or we have a guest presenter. We had Toronto Hydro on, for example. So those sessions are always really fun. Outside of the sessions, we also try to share the knowledge to other architects, homeowners, as well as other industries like municipalities, City of Toronto, for example. So if you do feel interested to join us, I put the link here. You can scan this QR code and we'd be happy to have you. If you just need advice or anything like that, you can also reach out to us on here. Thanks for the intro, by the way, Felix. So yeah, I'm from Weather Windows, but I did do a lot of carbon accounting at Sustainable with Paul, for example. And currently I'm actually working on the EPDs for Veda's products as well. So one of the important things that we want to highlight here is why architects so important in this riddle of reducing carbon. Well, first of that, for example, the building percentage went from 18 to 24%, as you can see, just from 2005 to 2018. So not only did it go up, but it's also a large chunk of the whole pie. The other thing you can see on this graph is that the electricity actually went down. So we had 17% in 2005, 2% now. So there's obviously a large chunk of that being used for buildings, which shows us how important it is to get off gas, fossil fuels, and go to electricity in Ontario. Another really important part is to get your estimates in early and try to implement any carbon reducing and net zero strategies early on. That will definitely reduce cost. A large chunk of people are hesitant to go towards net zero or low carbon because they anticipate a large cost. But if you implement those strategies early on, often that is not the case at all. So just a quick little tutorial before everyone else goes into their case studies of what we mean when we talk about carbon. There's two different carbon things we're going to look at. One is the material carbon and one is operational. So material or embodied carbon is a once upfront cost that you're going to invest into your building through materials, transport, all those things. Operational carbon is an ongoing carbon emission that's going to happen through the life cycle of your building through energy use. Together, we look at them as a carbon use intensity, and it's important to look at that throughout a number of years, right? Because if you can imagine, you're going to put a lot of it up front. If you're just looking at it over 1 year, you're not going to get that payback in operational carbon. So that's why we have the little X here. That's where the year goes. Most of the time, we look at around 30 years because that's a good lifespan of a material, but also that aligns with the 2050 goals. But you can obviously find your own balance there, depending on what you're looking at. For embodied carbon, we look at it at kilograms of CO2. You can calculate that with a number of tools, which I'll dive in a second. For operational carbon, we get our information from tools like Passive House, etc., and they will give us the kilowatt per hour measurement. That you just need to convert with a conversion factor that changes every year and obviously also drastically changes from province or country to country. You can see in Ontario, electricity is a multiplication factor of 30, so very low compared to gas, which is 177. When you're starting to look at the carbon emissions of your building and what decisions to make, there's kind of 3 different approaches in our head. One is going with your gut feeling, which I think we all have a really good one with that already. We know that things like concrete and spray foam insulation are not great when it comes to carbon, and we want to try to reduce those. So you can kind of see in this graph here that Builders for Climate Action has done what kind of the big bad 3 are and what other parts of the building are taking up in average homes. This study was done over 500 homes in Ontario, so it's a really good one to look at if you're just making initial decisions. If you're diving a little bit more in depth, you can use those tools that I was talking about. There's many more than this. I'm just putting 4 here because those are the ones that I've tried. And they have different degrees of accuracy, right? All of them are just estimates. That's something really important to acknowledge. We cannot calculate carbon down to the decimal. If you just want to go for a very initial budget estimate, Athena or Beam are great. Athena will give you the material carbon and operational carbon. User-wise, it looks very similar to HOT 3000, if that means anything to you. Beam is a lot easier to use, in my opinion, but only gives you the material carbon emissions. We'll dive into Beam in a second because that's a very popular one. If you're looking at a little bit more of a detailed estimate, one-click life cycle assessment and EC3 are great alternatives as well. So this is what Beam looks like. The reason why I'm going to go in depth a little bit is because I know a lot of the other speakers use that in their projects. So I'll set you up a little bit so you understand what you're looking at if you haven't used it before. So this tool is free, done by Builders for Climate Action, and it's Google Sheet-based. So it's really just a spreadsheet. And all you have to do is you toggle on your materials that you are using in your building. It will give you that number in real time. There's also the storage option here, which can give you your biogenic carbon payback. All these materials are 0 here, but if you will have one, I will show in green. The thing with Beam is that if you, especially for retrofits, you will only usually model the portion that's retrofitted, right? So in the presentations that you're seeing in the following bit, you'll notice that the numbers are quite different. That's because for a larger chunk of a renovated portion versus a smaller addition, those numbers will look really different because you're not modeling the whole house. especially in this graph, you'll notice this, it kind of tries to rank you on a per square meter basis. If you're only modeling a small chunk of the house, obviously that's not going to mean much. So this is really the numbers that you want to look at. It's breaking down your carbon footprint for every single wall assembly, which is really helpful. But again, we don't calculate any operational carbon here, so that would be on you to model in PHPP or any other software. This is one life cycle assessment. I just wanted to show it really quick because it kind of shows the difference in detail here. So this is actually a screenshot of our EPD for VETA that we're currently in progress with. You can see how it's adding all the different very detail-oriented materials. There's like 100 of the same thing every single time, and you have to pick the more accurate one. It also cares about things like transport, and then it will also calculate the construction emissions and end of life, which BEAM also does not take into account. So these two stages are new, as well as operational if you're building your whole building. And I will pass it over to Duncan. Duncan is a principal at DPA. He has founded it in 2017. And since then, he has helped over 50 homeowners make a new home for themselves. And one of the things he always tries is to make his projects as light on the earth as possible. So Duncan, with that, take it away.
Hello, my name is Duncan, as Kim said, and let's see if this works. I design green buildings. I wanted to tell you a little bit about my journey as an architect, as I've tried to build as well as I can. I'm going to take a little bit of a step back from the technical and talk about it in a sort of like how my story has gone. I've always wanted to build in the most sustainable way possible. But to be perfectly frank, I was never super excited about the aesthetic that went along with it. I was worried that if I sold myself as a green architect, I would have to design buildings like this. So for a long time, my position was, I'm going to build as green as I can, but I'm not going to tell anyone. And that's a picture of me smuggling in my green agenda. And I don't know if other people feel this way as well, but I personally felt like if my shingle said that I was a green architect, those were the sorts of clients that I would get, that I would attract. And if those were the sorts of clients that I attracted, then those other aspects of architecture that I cared about, which included ethereal things like in framing an aspirational vision of my clients' selves, as well as just looking cool, those would be the first things. The things that I also cared about would get chopped, and my buildings would start to look more and more like the one we just looked at. So I figured I'd try to position myself as a design architect, making as nice buildings as I could, and smuggling in the green part, which, you know, for me meant for a long time, high performance. It meant higher than usual insulation and air tightness. And that worked pretty well. I got some buildings that, you know, were insulated better than code, were more airtight than one would normally expect. And I got to focus on the fun sort of design details. In 2019, so 5 years ago now, I happened to find myself at the Passive House conference in Scarborough. And everyone was talking about how airtight they can make their buildings, how much insulation they could fit into their wall assemblies, and all kinds of devious ways of eliminating thermal bridges. It was great. And I myself had just finished working on a building that was largely ICF, and you can see it here, with big European Passive House windows. There you go. And lots of extra EPS that was just like stuffed here, there, and everywhere. And while we weren't looking for certification, we were looking for close to Passive House performance levels. But then up to the podium at this conference, stepped an architect by the name of Chris Magwood, who was then of the Endeavor Center, and he basically looked at the room and he said, "Look, guys, insulation and airtightness is great, and it really is. But the climate crisis is right now. And if what we're looking to do is reduce our emissions now, what we really need to pay attention to is the materials that you're building with and the systems that you're building with. So he showed us a chart that was this chart, in fact, that showed two different buildings. One which was, well, I guess 8 different buildings, but 2 different types of buildings. One type being code compliant, just a pretty good house, and the other being a high efficiency building. So the ICF building I had just finished completing was definitely this massive red column here. It was high efficient, but it was also extremely high embodied energy, embodied carbon. And I looked at the possibility of actually building a building that was code compliant, and using bio-based materials, we could actually get this sort of net negative in terms of the actual, we actually store carbon in the building rather than releasing a ton of it into the atmosphere. The audience at this conference was dead silent. And I thought about that ICF building that I had just been finished, and the monstrous emissions resulting from its creation. And I'm sure everyone was similarly having these thoughts. And for me, this was a turning point in how I was thinking about building well. And so I started to smuggle in low carbon materials into my projects too. This is a picture of me smuggling in the cellulose. Primarily, this was using less concrete and using more wood and more cellulose. However, and this is a project I was working on with cellulose being smuggled in. I'm not sure the client ever really knew that we used cellulose, nor did they care. And for me, a lesson I kept learning, however, was when I smuggled something into a project, because I suspected it was something that the client didn't care about, the builder didn't care about, but it was something I knew I cared about, it was very easily neglected or removed by other parties, especially in the wild west of single-family residential, where the builder often has quite a bit of leeway in terms of what they actually put into the building and how they build it. So when it came to air tightness, thermal bridge removal, increased insulation, and also when it came to bio-based materials, I kept arriving on site to find something completely different had been built from what I had drawn. And I came to the important realization that I needed to get buy-in from the whole team if I wanted to build well. After much trial and error, I realized I needed to start being much more overt in my priorities to not only table a green agenda at the outset of the projects, but even to set targets at the beginning of the project, both in terms of operational carbon and in terms of what I call the upfront carbon. Fortunately, I've had a number of clients recently whose objectives have aligned with my own. And I've started using the BEAM tool that Kim introduced, and also using woofing models that I've never used before, making them on my own projects. I started bringing these low carbon objectives to the table in discussions with clients and builders, and it's actually starting to work. And my buildings aren't looking super terrible. This one's, not the most pretty, but this is a success story. This is a 3-story MERB with commercial on the ground floor, where when we started working on the project, the structural engineer had in their drawings the elevator shaft and the stairwells were all concrete. The ground floor was a composite slab. And we managed to say, hey, you know what? There's a lot of places here where we could use wood. And so we ended up with wood eye joists for the ground floor with just a small amount of topping of concrete on top. And both the elevator shaft and the stairwells are all now made of wood. Very happy about. I also have a small addition currently under construction to where the client is actually a couple of environmentalists, people who are, live some of the most green lives of anyone I know, or low carbon, but they assumed that we were using spray foam. Until we got to the design table, they were like, okay, yes, so we're obviously going to spray foam in the walls and the roof. So it just goes to show to me that even the most well-informed of the general public are not aware of these things that are so obvious now, to becoming so obvious to architects in terms of the materials that we're building. So I was able to build a beam model, and I was very grateful to have that tool so I could simply show them, look, here is the carbon impact of building with cellulose, and here's the carbon impact of building with spray foam. And then my final success story is this one, which is a small accessory dwelling unit on a rural property near Strathroy. And the client here said, here, we want the greenest thing that we can build. And we also want it to, be awesome. So we're trying to do that. And I sold them right from the get-go, look, we're going to build a beam model. We're going to build a woofy model. And it was pretty really interesting, especially because this building being so small, it's heated by like fairly small heat pump and a high efficiency wood stove that is going to be burning wood that's harvested locally. They have a maple grove. I guess you call it a maple stand. And what we found was that when we crunched the numbers, that we actually had put way too much insulation in this building. We actually found that we were taking insulation away. We took insulation away from underneath the slab. We downgraded our windows from triple glazed to double glazed because we really found that it would have taken decades for that extra insulation to have paid off relative to their upfront carbon. So these are important lessons that we learn through the modeling process. And here is a beam model I built for that building where we were comparing doing a raft slab versus doing a stem wall. And again, I always thought that doing a raft slab would be better in terms of the overall emissions, but it was good to be able to actually show that. So that's it for me. Paul is up next. And Paul Dowsett is a leading thinker and advocate in the space of sustainability and architecture. Paul has been central to the introduction of sustainable architecture to the mainstream while practicing deep community engagement with equity-deserving groups of all backgrounds and abilities. At the core of Paul's philosophy and practice is the belief that design and construction solutions should be simple, sensitive, and sustainable. With more than 4 decades of local and international residential, institutional, and commercial sustainable design and project leadership experience, Paul is uniquely qualified to work with a highly collaborative design team for projects of diverse scales, types, and complexities. Paul is also the vice chair of NZAN. I'm going to, oh, never mind.
Thank you, Duncan. I'll take it away from here. Absolutely my pleasure to be here this morning. I hear we have a great audience of 60 some odd members, and that's great to hear. When I co-founded Sustainable, we took a little bit different approach than the approach that Duncan took in founding his firm. We actually wanted to be overt about our sustainability mission, so hence the naming of the firm. Doesn't seem to have hurt us. We've managed to design quite a number of high performance, lately low carbon, no carbon award-winning buildings. So we're just going to take a very close look at one of them here, which is a very specific but not untypical question in Toronto. We're looking here at a very typical double brick Toronto semi built somewhere around 1915. There are scads of them across the city, east, west, north, south, all around. And this client had already gotten rid of their gas furnace. They had already installed an all-electric air source heat pump for heating and cooling their house. They knew that we have a very clean, very carbon clean electricity grid in Ontario, and just providing the heat through efficient electricity of a heat pump would be much better than a gas furnace from a carbon point of view. This client is very cognizant about carbon. They had already replaced the windows in their house. They'd used Veta windows. Thank you, Kim. They had already insulated the attic. So they had done the very standard things, the things that we know to do. And they were sitting with the question of whether to overclad or not overclad. At the time, the conventional wisdom that we also believed, the conventional wisdom that for all these buildings, that we needed to do deep energy retrofits, that we needed to super insulate them and make them super airtight, like passive houses. We had to use sort of the passive house interfit model in order to make these homes efficient. This was the conventional wisdom, and that was the question that this client came to us with. So next slide, please, Kim. So we looked at 4 options. We started with the baseline, their existing condition. It's an existing double-wide brick house. It already had an air source heat pump. It already had triple glazed windows, and they already had an insulated attic. So that's where we needed to start, as this is how it exists right now when we do our modeling through BEAM and through Passive House, through PHPP. The second option was then quite simple. We were going to add an air barrier, a membrane air barrier on the outside of the brick, and add wood siding outside of that. Building on that into option 3, we still have the membrane air barrier, but below the wood siding, we would add 3 inches of mineral wool insulation. And then in option 4, we would swap out that mineral wool insulation for wood fiber insulation. So those were the 4 models we were going to model. And in the model, we found that the operational carbon at the baseline, so as it sits, nothing changed. There's a quite modest 230 kilograms of carbon per year. So that's its annual use, and that's not a very high number. It's a better than normal number. It's not an extraordinary number in any way. The interesting thing, of course, is because in the baseline, we're not adding anything. All the things have already been added. We're sitting at a 0 embodied carbon debt. So if we left things the way they were. In option 2, we're starting to add an air barrier and some cladding. Logically, the operational carbon goes down, but because we're adding material, the embodied carbon goes up. So we actually are incurring a debt of carbon that needs to be paid off over time by those operational carbon savings. And so it's quite simple math. You divide 1368 by 158, and you get something somewhere, some number of years it's going to take to pay off that carbon debt before we actually start saving carbon. Next, please. Similarly then for option 3, where we've added the mineral wool insulation, yes, the operational carbon goes down, but the embodied carbon has gone up substantially. So now we have a very substantial carbon debt that we need to pay off over time. Next. And then we modeled option 4 with the wood fiber insulation, with the information that we had available. And yes, again, the operational carbon goes down. Oddly, the data that we had available to us also showed us that the embodied carbon went down. We chose to question this. There are reasons why it is questionable how accurate the data available to us, and that's very important. We have to rely on the data available to us, but we are allowed to look at it a little bit sideways and question it. And this was one of those cases where we did, because there are real questions that, like, can any manufactured product actually end up with a negative embodied carbon? The other reason why we were left this sort of mostly as a test, at the time, the cost of wood fiber insulation and the availability of wood fiber insulation, the cost was high and the availability was low. So it was really just sort of an outlier test case. Next, please. And so this graph on the left, you can see at the bottom line, the sort of bright green line, is the wood fiber insulation, and it's the outlier that we really used as a test. But as Kim suggested, we were looking at the 30-year mark for our carbon use intensity, and when you follow that dotted line up the center at the 30-year mark, and you're looking where it crosses the baseline, the option 1 and the option 2 lines, they're really close together. There's not much difference there in choosing what we do. So the choice was made by the client that really the most effective thing to do in those three choices was to leave the baseline as it is. So the client chose to, not incur a further carbon debt, also didn't incur a further money debt, because actually didn't change anything, had already changed the things that could be changed, and then decided to use that saved money. The very first slide that I showed a really nice wooden front door. That was actually the thing they spent their money on, because they had a lovely original front door in the house that was leaky as heck. And so they replaced the front door and got some air tightness and some insulation in the front door, and actually use that to improve their baseline. Next, please, Kim. And we also thought that we would model, because we did speak in the beginning about how carbon clean our electrical grid is. And so all these models that we had done previously were just looking at electrical operation of this house, so quite carbon clean operation, because they had already gotten rid of all the gas fired appliances. But we did feel that we needed to show what that existing baseline home would look like if it was burning gas still. And that's the red line. And you can see it's just very quickly going off into the stratosphere. So that does reinforce what we know, that the most effective thing to do to decarbonize homes is to get them off the gas, and then look at sensible retrofits like topping up attic insulation, changing windows, making them triple glazed where that's appropriate, sealing leaks, working on air sealing and air tightness from the inside. Really logical things. So not so much deep energy retrofits as reasonable energy retrofits. So that's what we are now in the process of promoting, is get off the gas and do reasonable energy retrofits. And which order you do those in doesn't really matter. The getting off the gas will drop your carbon emissions by 90% or more right in one fell swoop. Next, please, Kim. So next up is the lovely and talented Carolyn Moss. Carolyn is a graduate of the architecture program at Carleton University. Carolyn is one of the first LEED accredited Canadians, is Passive House and Net Zero certified, and has delivered deep energy retrofits. Sorry, Carolyn, I just stole some of your thunder there. And has delivered deep energy retrofits on existing homes in Toronto for over 20 years. Carolyn is principal at Moss Sund Architects, is founder of Homes to Zero, and is chair of the Net Zero Architects Network. Take it away, Carolyn.
Thanks, Paul. Thanks so much for the introduction, and really happy to be here today as well. It's really interesting to hear all the different approaches from the different architecture firms. We talk about this each month at our Net Zero Architects Network meetings, and not always agree on exactly the approach that's being taken, but in general, we're all involved in single-family homes, mostly retrofit projects in Toronto, and it's been really interesting learning from each other on how our journeys have gone. So Moss Sund, we've been around for 20 years, as Paul said, and prior to that, for another 5 years, I had my own design firm. I started, being concerned about the environment way back when I was in university. I built a little off-grid passive solar studio beside the architecture building at Carleton, as the first, testing myself, these principles for myself, and went on after that to do, some passive design houses, and then, as we went along, it was similar to Duncan's story. We wanted to design really great buildings, and we wanted to make sure that they, the insulation, I'm really excited about all that stuff, but at the end of the day, the homeowner wants a really nice place to live. That's what their day-to-day life, that's how it's going to, the comfort is important, but utility savings and all that, it's not that exciting. Living in a great space is. So again, we were sneaking in insulation and just adding more insulation than code required, better windows than code required. And again, I'm talking, this is a long time ago. We didn't have BEAM. We didn't have energy modelers, right? I did Fortran programming at university, right? There was no CAD. So this is like, we did the best we can. We didn't have Google to say, you know, what's the R value for a net zero house? It didn't exist. And so there were energy models. It took a long time and was very expensive to do. And on the fees that you were getting for a single family house, it just didn't make sense to model each house individually. We just couldn't do it. So what we ended up doing was taking the assemblies that we typically use. So typical houses in Toronto, either you're going to have a double brick house, you're going to have a wood frame house, and saying, okay, for that house at this point in time, what kind of assembly do we think we should use? How much insulation should we put on that? And we sort of evaluated them based on the health of those materials, the energy reduction potential, the cost of that material, market acceptance, and also the space required. Because again, some of the houses in Toronto are very small to start with, and it'd be hard to convince a homeowner to give up 6 inches for insulation. So there was this big balancing act that had to happen to see what this kind of sweet spot was for the different kinds of typical assemblies that we used. And now we still do a similar approach, but we've of course added embodied carbon. It was something that it wasn't, you know, while we were all on gas, operational carbon was really the easy thing to chase. But now that we can electrify buildings really easily, the embodied carbon, especially considering the amount of buildings, housing that needs to be built very soon, embodied carbon is really going to be critical, because the next 10 years in terms of the climate crisis is really something we really need to knuckle down and reduce the carbon as much as we can, as soon as we can. So that's in the embodied carbon. And so our clients weren't chasing, they weren't looking for certifications. They weren't looking for, they didn't need a number at the end of the day that said exactly what their embodied carbon or operational emissions were going to be. So we sort of went, was close good enough. Let's get them comfortable, really beautiful places to live, use less energy than the typical building, and we're healthy for them to live in. So unfortunately, my slides are a bit laggy. I might, here we go. So here's a recent case study. And as we got more and more knowledgeable about the, again, through Chris Magwood, amazing resource. I'll talk about that more in a minute. But looking at really embodied carbon. And so how do I do a deep dive into this embodied carbon thing? And I was like, okay, I'm going to test it on myself. So this is an addition to my little cottage. The original picture on the top right was where the original cottage was. And then we did a passive house level addition to it. And so also testing my passive house on myself and the process that it would take to get a passive house certified addition. For those of you that know about passive house, to do a single story, very small, exposed floor structure and get it to meet passive house is pretty much impossible. But we did actually make it there. I just haven't done all the final paperwork. But also to make it low carbon. And so this building, aside from the metal roof and the glass in the windows and the piers, we went on piers for this project, again, to reduce the amount of concrete being used. Aside from that, it's all natural based materials. We used a double stud wall filled with cellulose. There was 5 guys there blowing cellulose into these walls and roof for 2 weeks. Our 60 walls are 100 in the roof and are 100 in the floor. It's very, very quiet in this building, very quiet. And it takes very little to heat it. We heat it with a very efficient wood stove with outdoor air intake. And so In the end, though, it's pretty standard wood frame construction, wood siding, wood windows, wood floors, wood finishes, no sheath. Like, we tried to reduce materials. There's no sheathing. We use wind bracing. So in the end, I have done the PHPP. It meets the energy requirements. We haven't done the beam yet. It's that whole cobbler's kids have no shoes program. I will run the beam, and I expect it to be well carbon sequestering. But can this then translate? This is my own project. I could spend, every day that I was up there taping things. Can it transfer into a tendered project? So this is a project we did just after that, and it's for a client. It's an addition to a dormitory at a private school. And the client was interested in environmental issues. They had some LEED buildings, but this one had a very strict budget, and they weren't interested in getting it certified. And so it was not in the brief. But I sort of said, I think we can get this done on the on the budget. And so that's the approach we took. Again, standard wood frame construction. We just use low embodied carbon materials. Again, cellulose, wood siding, wood structural systems, all electric for the mechanical systems. And then, really talking to the contractor, who was amazing and was really excited to move in this direction, and did lots of work and research themselves. Things like they got the gravel in. It wasn't easy. So gravel is an insulated foamed recycled glass product that you can use in place of gravel and insulation under your slab. They brought that in from the States. It's got Gutex, wood fiber insulation on the side. Again, cellulose insulation, wood frame construction. And so it ended up coming in under the budget, and the contractor did a great job building it. And in the end, we had over the baseline. So typical house in Ontario would have between 150 to 210 kilograms of carbon per meter squared. That's the typical range for embodied carbon for residential. And this one came in at 79 kilograms. So about 55% reduction. We made some switches like during, just at the kind of tender stage, where we switched the mix of the concrete, no change to the cost, and brought down, things wherever we could just by tweaking, working with the contractor. So I think we could do even better, but it was a good lesson learned. But 95% reduction in emissions in terms of the operational side, again, because it's all electric. So these are the tools that we use. Kim's mentioned them, we've all mentioned them, but Builders for Climate Action, such an amazing resource. Chris Megwood is really moved the needle on embodied carbon. One of the things that I find that's most easy to use is they have a report called the Material Carbon Emission Guide. And it's the chart that's kind of in the middle of the page, where you can just go in and look at the embodied carbon or the emissions related to various materials. And I was quite shocked by some of them, like mineral wool, quite high compared to fiberglass bat even, which typically I was always using mineral wool. Of course, there's choices we all have to make. There's times that mineral wool makes sense. But, switching out for fiberglass bat, that's a pretty easy change. And then again, cellulose. So they have these charts for insulation, for cladding, for concrete, for all sorts of different materials. And it's just an easy way to swap out materials to make better choices. Again, we use the beam calculator sometimes when we want to really, again, model the difference. Like Duncan had said, just the difference between two kinds of slabs. If we just want to see what difference that will make in terms of the embodied carbon or what things we can change, we have a base model in beam, and then we can switch out various things. We use HOT 2000 just because we have to. It's painful, but because it's the one that NRCan uses, we do use it sometimes for energy simulation. PHPP, again, it's kind of a beast, but we have a baseline, and then we can test various changes, and then we have some websites like Green Building Advisor and buildingscience.com that we rely But after all this, you know, many years of working on houses, and going with this approach of how do we make it just easier and faster to evaluate what the right choice is. It's not easy. That's why we formed NZAN, to talk amongst ourselves to say, how can we make it easier? So in 2020, just before the pandemic, my business partner, Simona Sund, and I, we thought, let's take an entrepreneurship course at Western. And so we did. And one of the things that came out of it, we came up with 3 ideas. One of them was on recycling or getting back unused materials from building sites. The other one, basically the Net Zero Architects Network, and the third one being Homes to Zero, which is, and our goal was just to make it easier and faster and less expensive, because we've done all this work to design a house to make it more energy efficient, lower embodied carbon, but we know that all the houses on the street are pretty much the same as that house. And for each of those people to have to then replicate the same thing, it just didn't make any sense. So how can we take what we've learned and be able to pass that information on to other homeowners, to architects, to designers, to contractors? So fortunately, one of my clients, previous clients, is a data scientist. And so she's like, okay, I'm in. And so she's had the task of basically extracting the 20 years of knowledge from my brain and some of the NZAN group's brains as well, to combine, use machine learning and some AI along with our expertise to automate that retrofit assessment process. So that if you want to give a report to your homeowner that says, these are the levels that we should meet to meet net zero, these are the top 3 things that you should do in your house to make the biggest impact. And we evaluate things like emission reduction, utility cost reduction, rebates that are available, the cost of that upgrade, so that homeowners can get a report that says, okay, this is how they can understand their house better to start, and then this is what we can do to do our part in the fight against climate change. You know, when they're renovating anyways, like Paul said, you know, if you've already switched to electric, to start to spend money on overcladding, if you weren't, you know, renovating anyways, might not make sense. But if you're doing a big renovation, let's get you the information you need to do the right thing. And so we're really hoping that by automating this process, we can get the information to more people faster. So if anyone's interested, you can go on our website at homestozero.ca. If you're curious about the carbon emissions from your home, a lot of people might, well, I don't know, some people don't look at their bills at all. But if you want to know the emissions from your home, the average home in Canada has 5 tons of emissions. And that's 3rd worst in the world. And so understanding what your baseline is really important. So if you go on to homestozero.ca, we have a little thing called a climate score. You can just put in your utility use for the last year, and we'll let you know what your carbon emissions are. So thank you very much. Now we're on to Brad Tapson. Brad Tapson Design was founded on the principle of finding the right balance for every project. A graduate of Dalhousie University's Master Architecture program, Brad brings to the table more than a decade of experience in high-performance design and a passion for creative problem solving. BTD brings sustainability to every project by focusing on simple strategies, employing context-sensitive interventions, and using the right amount of the right materials in the right place. Take it away.
Thanks, Carolyn. So I'm happy to be here. Really excited to be sharing in the sort of learning about this field of carbon knowledge and prioritizing. And so I'll share a case study project here just to talk about sort of my approach to this in this particular instance. And how that worked out. So this is the project is a fairly typical bungalow in Scarborough. Young family was looking to increase the amount of space that they had for their sort of growing family. Very eco-conscious, had some priorities, obviously, that they needed to balance, as every project does. And we're very concerned with making sure that the quality of the high performance work was there, and that their sort of tight timelines were also met. So we started out the project by really digging into those priorities and identifying the three top priorities: budget, timeline, and sustainability. Budget, self-evident, every project. I've yet to find a project that has too much money. The timeline, in this case, they had a young child who was about to start at a new school, and they wanted to sort of be into the house before that happened, so that they could, be settled and make that transition nice and easy. And then sustainability, for these folks, they sort of were finally in a place to have their home match their sort of lifestyle and their values, which was great. And they were taking this opportunity to turn this into their forever home and to do it the right way at that time. So we dug into what exactly sustainability meant for them. The question of to certify or not to certify with Passive House. They weren't concerned with certification or a stamp or a badge or anything like that, but they did want it to perform really well. And so, we took the kind of pretty good house approach, not worried about meeting certain thresholds that were set by certification organizations, but trying to perform as best we could, using passive strategies as much as possible, planning for the future. So, making the roof solar ready for the future when they can afford to do the next phase of work, thinking forward to aging in place in the home and things like that. And then also brought to the table was this discussion that we've all been talking about today of operational versus embodied energy. So they came to me with an idea of what net zero means, what sustainable architecture means. But when we dug into that a little bit, it involved a little bit of kind of education and enlightenment, and through that discussion. So we presented some ideas here about what that means, and in focusing in on the wall assemblies in particular is just really easy to illustrate that. We've got kind of the code minimum wall here that people are familiar with, the 6 mil poly, the fiberglass insulation, the Tyvek or whatever non-Tyvek building paper, and the foam continuous on the outside. But then we've got what could provide a net zero operational assembly here with spray foam, with some quick applied insulated panels and things like that, but really focused on operation, not on embodied energy. And then we've got here an example of a wall assembly that actually comes from a prefab company, which is focused on Passive House and or high performance building, really with a focus on natural materials and the carbon equation. So, we discounted the code minimum wall assembly right away. They weren't interested in that. They came to me because they were looking to, go beyond that. But we did this comparison using the beam tool between the sort of net zero energy focused assembly on the left here and the carbon conscious high performance wall on the right. And you can see right away the carbon intensity of the exterior walls, the cladding, the floors, the roof are all, massive sort of anchors here. Whereas in the carbon conscious side, they're a lot lower. And I'll note that this comparison was only done for the second floor for the new work. So we did do some work inside the existing house, but this is, this comparison here isn't counting for the existing brick, the foundation, the carbon heavy things that happen when you do a new build. So we sort of took advantage of the existing conditions there as a baseline, and just focused on the embodied carbon of the new work. But it became really obvious that there was a direction we wanted to go here. And so we were able to work with that prefab company and meet sort of all three of their priorities. Came in with the budget in mind, came in with the timeline, and really delivered a carbon conscious high performance house. And the prefab was really fun to watch. So I would encourage everyone to look into that. And there's a lot of different sort of ways that can go, but in this case, all of the sort of stakeholders were aligned in their priorities here, and we delivered something that really worked out for everyone. So with that, I will introduce Joel. Joel is the principal at People Design Co-op. He's a leader in sustainable design, focused on the development of affordable housing. His experience focuses on advancing the health of individuals and communities, and he advocates for the use of techniques and materials that reduce carbon, promote healthy environments, and care for the planet. So take it away.
Sorry about that. I couldn't unmute myself when I took control. Thank you, Brad, and thank you to all the other panelists and everyone who's here today. I'm really excited to be here. I think this is such an important topic, and I think it can be really overwhelming. So I think if there's any big takeaways, it's that it doesn't have to be that. So I'm going to talk a little bit about some of our projects and kind of where it's taken us. I think our approach is similar to a lot of the other panelists, and then we look at kind of where else this can take us and what else we need to consider when we focus on low carbon or net zero. So I'm going to start by talking about this house, which is one that's a pretty ideal scenario. It's one where the client wanted to came to us and wanted to construct a home that's energy efficient, broadly sustainable. So we shifted our focus from energy efficiency to carbon efficiency and started looking at low carbon materials and systems from the very beginning, low operational carbon with all electric systems for heating, cooling, and partnering with a build partner that was already an expert in this work. Sorry, these slides don't seem to be changing for me. There we go. So when we get to work in an ideal scenario, there's a lot we can do, but there are still some very real barriers. Sometimes those barriers are outside of our control. They can be supply chain issues. They can be cost. And we know that foundations are the biggest source of emissions. So with this building, when we started this project, we designed a building with this in mind. We designed a building that had virtually no concrete and looked at a wood foundation system or a helical pile system with a wood framed floor. And what we found using BEAM was that that removed or allowed us to have a very low embodied energy baseline to work from. But through the pandemic, when we saw the cost of wood kind of skyrocket, we were forced to kind of shift to a more traditional foundation approach. And I think this really highlights, in this, we were able to see that the addition of a typical foundation added as much concrete or as much carbon as was originally in all of the other materials combined. And when we look at case studies like this or some of the other ones we've seen, Brad's was a really good example, Carolyn's as well, with virtually no foundations in an addition, we can see the impact that certain parts of the building have. So another project where, again, we were able to look at a really ideal scenario and a client who was really committed from the very beginning. We were able to prioritize the use of low carbon materials like Gutex and wood fiber insulation, eliminating things like structural steel while we still wanted to achieve large open spaces. And some of those design decisions early on allowed us to achieve really significant results. Again, the challenging thing here was foundations. Building below grade space, building parking space, which were both defined as really important for the project, we still need so much concrete. So even in an ideal scenario, we aren't really going far enough with materials, although we do have a lot of really great opportunities. So what we start to look at is where else can we push beyond the status quo? So with this project, the client was open to sharing a lot of their learnings throughout the process. And we were able to host through an organization or an initiative called Future Builds, a panel discussion where we were able to share our wins and our challenges. And this is a really essential part of all of this work that we're doing, because we're not all starting with a blank page. And so with this particular project, we were able to create an opportunity to educate a cohort of emerging racialized developers. And that's a really important reminder that it really is rooted in a larger climate justice movement, and a really important prompt to think about who this is actually serving. This shouldn't just be a luxury for the wealthy, and it should in fact be the new standard. And maybe even more importantly, this is a necessity for our most vulnerable. So when we think about this work really is rooted in climate justice, and we really can't have this conversation without thinking about that. So this is where we spend a lot of our time today, working at scale with deeply affordable housing. But as we heard and saw with some of what Carolyn shared with Homes to Zero, it highlights an incredible pinch point in retrofitting our city. Our city right now has, I think, a little over 450,000 houses. And Toronto has set a goal to half that by 2030. And if we were to cut 100% of the emissions from half those houses, that's still almost 250,000 homes that we need to renovate or retrofit to some degree in the next 5 years. So there's kind of three main things that we're focused on when we look at this work, that are maybe tools we can think about beyond the tools like Beam and the digital tools that we have to help us with design. One of those things is we need to build a workforce. Two, we need to create a market for these new materials, or materials that are maybe less common, less familiar. Sorry, this is very delayed, I apologize. I'll just keep talking, and I hope that the slides will catch up. So if we're creating a workforce, we have to think deeply about who that workforce is. And we need to find ways to prioritize working with racialized and women-led builders and tradespeople. So some of the ways that we've been focused on this is hosting events like this one, which we titled Building Community. And this was kind of unique because it brought together builders, it brought together suppliers, other industry professionals, as we prepared for a closed tender for affordable housing projects. And to host an event like this, we partnered with an organization called Building Up, who, along with being an exceptional high performance builder, also works every day to help build a green workforce. They in fact run a trades training program that gives people experiencing barriers to employment a pathway into the trades. And so it's just an example of how being really intentional about some of these partnerships can allow us to push beyond the traditional kind of designer-builder relationship. And then thinking beyond that, when we look at affordable housing portfolios, and there's a lot of scattered housing portfolios that exist just in the city of Toronto, it starts to kind of suggest the scale that we're able to work at. And if we're relying on kind of traditional supply chains that are driven primarily by a capitalist model, it's going to take a really long time. We're going to have to wait for someone to build a business case for a lot of these materials. And we're already seeing some of these challenges with products like wood fiber that we've talked a lot about today, where it's a product that should, in theory, be readily available. But in the case of our project, and Carolyn's may be the same, we had to actually import that material. And even though there are manufacturing, or there is manufacturing starting just across the border, we're not yet seeing those products come to market here. But when we start to see the scale that we're working at, we can start to build a market for these materials. Within the current nonprofit scattered housing portfolios that we already have today, there's well over 1,000 homes, and we can think about procurement of materials. We can think about circularity and where materials go when we remove them from projects rather than just into a landfill. And we can think about healthy low carbon materials as direct replacements to what exists on the market today. And that's really essential. I think in all of the projects that we saw today, we saw good examples of how we can make that as easy as possible with materials that you can go buy off the shelf. If you want to go buy mineral wool insulation, you can walk into a hardware store and you can buy that product. But if you want to seek out better materials, you often need to do additional work. So there's work to be done to really make it easy and quick to substitute these materials. sorry, this slide is just a kind of a map of some of the affordable scattered housing portfolios, and you can already see kind of the sense of scale that exists in the city, the diversity of housing typologies. And again, this is all just low-rise residential. And so that really allows us to create a new market. So maybe the last couple prompts that I'll leave everyone with is we often look at changes like this as being really disruptive to the design process, disruptive to the construction process. But it doesn't involve a single intervention point, and along the way there are intersecting priorities that lead us toward becoming responsible stewards of maybe just not a building, but the land that the buildings sit on, which is ultimately what we're most responsible for. So throughout the process of designing and constructing a building, regardless of whether we're renovating or building new, there are a number of different things. We heard a lot about commitment from clients and builders and partners at the beginning of a project. We saw good examples of using what we already have and building only what we need. But that really stretches through the entire process, and I think we're about to head into a discussion period. So there's lots of good questions. There's lots of dialogue. There's not enough time to cover all of this in a brief presentation. But I would just leave everyone with maybe these prompts. And maybe I'll end with this. This is a photo from our building community event as a reminder that as architects and designers, we aren't going to solve this alone. And it really requires us to bring a lot of different folks together to the table to make this happen. So maybe with that, I'll turn it back over to Kim, our moderator, and we'll jump into some Q&A.
Perfect. Thank you all very much for a great webinar. And this is just a friendly reminder for all members. If you do have any questions, now is the time to post them into the Q&A window. And all of these will be addressed right now in the Q&A session. Thank you.
Thanks, Felix. And thanks everyone else for the great presentations. So yeah, as mentioned, we're going to do a little Q&A round now. I see 4 questions so far. So just in terms of timing, just throwing that out there, we'll try to get everything done before 12:30. But if anyone is left at the end with questions, here are our emails. Reach out to us individually or reach out to the Net Zero Architects Network if you want us all to look at your question. So the first question from Anonymous is, I am interested in building retrofit and how reducing the demolition and disposal of materials like concrete, which have already generated carbon, can be reduced. So first question is about demolition. There's a second question, same attendee. Any ideas on low carbon alternatives for high carbon materials? You want to jump in on that? Joel, go ahead.
Yeah, I think that the question about demolition is something that's really important. We often look at demolition as just being get it out of there and get rid of it before we can start building new. But we really need to start to shift towards a more circular model. And fortunately, there are a lot of good examples of this. There's, for example, in Toronto, there's an organization called Ouroboros Deconstruction. And what we're seeing is that we're actually approaching cost parity with deconstruction instead of demolition. And that essentially allows us to divert a lot of materials away from landfills and see them be repurposed. They've even been exploring regrading lumber for structural uses. So there's a lot of great opportunity for deconstruction instead of demolition. And maybe I'll let other folks jump in.
Thanks, Joel. I'd like to build on what you just said. I think that, following the principles of the 3 R's of recycling, reduce, reuse, recycle, in that order, and they're in that order for a reason. So I think one of the most ideal things, as a bunch of us stressed, and as Joel certainly stressed, only building what you need. So in this case, it'd be also only demolish what you need to demolish. So the first idea might be to reuse existing concrete foundations, use them in situ as they are, and build upon that. Use that as your design starting point. Utilize what's already there, as we showed in my little example. The additional embodied carbon of the thing that you reuse is actually 0. So the additional embodied carbon only comes from adding things to what's already there. So I would stress really try to utilize what's already there, use it again and again and again.
Yeah, I build on that as well. We had once a client come to us and say, you know, we'd like to put a big addition on the back of our house. And when I evaluated the program that they need, you know, how many kids they have, who is living there, and the square footage of their house, I was like, you have plenty of space. The average square footage per person in Canada is 750 square feet per person in a house, which is, again, I think second highest in the world. In England, it's 330 square feet. And in Hong Kong, I think it's 145 square feet per person. So we have massive houses, right? And so this client, they came to us, I was like, you've got enough square footage. You've just got this like crazy stair in the middle that's taking up all the space. If we can reorganize your house, you've got enough. So that saved them the money of the big addition. They got a really great renovation done, and there wasn't that embodied carbon of the addition. So it's, you know, keeping what you can, building what you need, educating people on, like, I think that's a really important thing that we all have to keep in mind is how big the houses are getting. Do they have to be that big?
Mm-hmm.
And can we keep a house that's there instead of making it new? So it's a great question. And then in terms of replacing high embodied carbon materials, I would point you to the Builders for Climate Action, that the guide that I gave you. It's so easy to just go in there. What anyone who's designing homes that have brick exteriors, you're going to have one look at the chart for cladding and reconsider that that decision. The amount of embodied carbon in brick is so far off the charts. That and XPS. So just go to those charts and say, okay, I was thinking about brick. What are some other options? You could use steel cladding, you could use aluminum cladding. If you can, use wood cladding. You know, it's not always possible, but those charts are just a really, really simple way to switch out materials for lower carbon options.
All right, I think that answered the first question. I'll jump on to the second. This is from Lauren Rose. This is along the lines of my questioning of changes to the OBC and energy efficiency. Triple glazed windows can add so much to energy efficiency, but what is the carbon footprint of making and transporting another sheet of glass? Nobody could ever give me a proper answer to this question. I'll try to chime in on that first, if that's okay, since that's very close to what Veta is currently looking at. Because we obviously, you know, we want to make sure we're up to date on this stuff. And as Carolyn mentioned earlier, we used to, until now, be mostly about energy efficiency. So, you know, adding more panes of glass and more insulating layers in between, the better. But now we're looking at embodied carbon, especially if you're going all electric. So is that really still worth it? So our EPD research so far has shown yes. Just because the amount of glass that you're adding, it adds about, if you're looking at a wood alloy window, which is what we're doing, it adds about 10% on top. It is not a lot, and it really depends on what kind of energy source you're on, obviously. But even with electricity, so far it seems to be worth it. We're not done with the EPDs yet, but we do have a small little example on our webpage. So you can go onto Veta, or I can also send it to Felix. Maybe you can send it out. But what I would recommend is ask your window manufacturer if they have an EPD. Compare them, because usually they have one for double glazed and triple glazed, and then you can actually do the math. Couple other things I want to mention is, number one is your window is never going to be as good as your wall assembly, right? So the window is always one of the weakest points. If you're trying to reduce carbon while still keeping your wall pretty efficient, you are better off reducing the amount of insulation a little bit. So let's say you want to go for a 3-inch exterior rigid. Maybe it's worth it to only do 1.5 instead of reducing that extra pane in your window, just because that window is already pretty weak. Your wall is already so strong that it will be able to take that a little bit more, and you're gonna get a much bigger benefit than just removing a pane of glass. For large windows also, what we often face is once you remove that extra pane of glass, we actually need to up the thickness of the glass. So usually by default, we go with 3 panes of 4mm glass. If you remove one, you're going for double pane, you're gonna have to go for 6mm. So then at the end of the day, you're creating the same amount of glass. You're gonna save one spacer and the argon glass in between, argon gas. So, you know, there's still some saving there, but you're really reducing that savings, and you're making your window very inefficient. Last point from me is if you look at other things besides carbon, because that's not all there is to architecture, right? And we mentioned that earlier. You will get a much better sound performance out of your triple pane window. You will not feel cold in front of it, right? So yes, we don't need to save as much energy potentially with electricity, but we still don't want to be cold if you're sitting right in front of your window. And there's just so many other benefits to a triple pane that have nothing to do with efficiency or carbon. So, but with all that being said, go to your manufacturer, ask them for an APD, or ask me and we can chat about it. Anyone else have anything to add to that?
I'll just quickly chime in that it's something that we're working on again at Homes to Zero, that we're going to work with Village for Climate Action to look at embodied carbon of the various retrofits. And so we're modeling some things like, same thing for a heat pump, right? What's the payback on a heat pump? If you're switching out a furnace, it's, you know, when do you do that in the life cycle? And so we've, I think, modeled, it's about 5 years or so that the amount of energy that it went into making that heat pump, it's going to pay off. And don't quote me on that. We're going to update those numbers, but that was sort of our first go at it. But it's always interesting, like Kim said, there's always that, well, it depends. Because it depends, for example, with the triple glazed windows, what your fuel source is. So any energy efficiency measures you're taking in terms of reducing carbon, if you're on gas, they make such a big difference. But if you're on electricity, they don't make as much of the difference. If you've got a wood window, adding another pane of glass, not such a big deal. If it's an aluminum window, then maybe, you know, you're changing, like, so there's lots of, it depends. And so again, evaluating them each time, it's hard, but hopefully very soon, Homes to Zero will be able to help you with that, so you can make those combined decisions quite easily.
I think we're good with that one too. Okay, so we have a new question as well. So I have 3 left so far. Next one's from Jane Osmo. What happens if there's a power outage in a region and my house is fully electric, including the furnace? It's a very valid concern. What do you guys have to say about that?
I think it's the same thing that happens if you have a gas furnace. It's not going to work. So, Paul?
Yeah, sure. I'll help out here. Yeah, Jane, we get asked this question a lot. I work with a couple organizations called the Pocket Change Project and Toronto Home Retrofits, where we're encouraging people to electrify, and this is very often, you know, one of the first questions we get. And a lot of people don't understand, as Carolyn says, that, you know, modern gas furnaces don't work without electricity either. Modern gas stoves can be made to work without electricity, like with a barbecue lighter, you know, in the event. But most gas appliances have electrical starters on them that need the electricity running. And so what we've actually found is that a good thing to do, whether you're electrifying or not, is back to what I talked about earlier about those reasonable energy retrofits. Looking back to 2013, when in Ontario we had that ice storm that took down electricity for a lot of people for a long time around the new year. The homes that we had designed for people actually became refuges in their neighborhood, the retrofit homes, because they had reasonable insulation and they had reasonable air tightness, and they stayed warm a lot longer than their neighbors' houses that were not renovated. So it's the combination of electrification plus reasonable energy retrofits that is the full package. It's not just the one thing. And yes, you know, your heating system won't work, but your house does become a refuge in the neighborhood because it stays warm longer. And one of the things we mused about is, did the houses that became refuges in the neighborhood, did they stay warm longer because there were more bodies in them as well, more warm bodies, because they were taking in their neighbors. So, you know, open questions there, but the answer is it's a combination of the two things.
In Toronto, the frequency of power outages is very, very, very low. Certainly in the country, I'm totally aware that my power goes out quite often. And so for more than just the heating system, again, very well insulated home, it's not such a big deal, but for the other systems, it is. And so, you know, you just, in those cases, you would anyways, gas or not, have to have a backup. So it's really interesting question that does get asked a lot. And it's unfortunately, that's, I don't think that much of an issue.
All right. Good answers. Next up, we got Anonymous. Comparing gas with nuclear may not be fair unless you're considering the carbon that goes into the generating plants. Not really a question. I don't remember who made this claim. Who compared gas with nuclear?
I think that was probably me when I was talking about, you know, Ontario's electricity being carbon clean. It's not nuclear clean, but it is carbon clean. And I actually agree with the statement. Yes, it takes a tremendous amount of concrete to make nuclear plants. You know, it takes probably takes a tremendous amount of, I should say, probably it does take a tremendous amount of carbon to make hydroelectric plants as well, and all sorts of things in those systems. So yes, that is absolutely something that we have to look at. It's not something that we're looking at here. We're just kind of, you know, looking at those as sort of those, you know, sunk cost externalities kind of thing, because they already exist. We just kind of have to accept them. But it's an absolute valid thing that has to be looked at in the future, long term, I think. But please, others chime in and help out here.
I mean, like we've mentioned a couple times, there are like none of these analysis tools are perfect, and there are certain life cycle elements that aren't accounted for. So we do need more work in this area. Absolutely. But yeah, working with the information that we have available, I think is what we can do right now. And it's what we can do at every step, is working with the best we have.
You know, I agree. It's an interesting question that's raised, because it took a lot of energy and concrete to make the nuclear plant. It does to make gas plants. It does to make hydroelectric plants. I don't know for the amount of energy created by a wind farm or solar. It would be really interesting to see the embodied carbon of each of those ones compared somewhere. If somebody has that information, I would love to see it.
We answer that. Next, another anonymous question. What about making the cost of disposal of existing primarily commercial buildings expensive enough that retrofit becomes a profitable choice? So this is commercially focused. Basically, at what point is retrofit the financially sensible option compared to tear down, right?
I think maybe the question that's underlying here is, why aren't we adding the real cost to the decisions we're making, and instead we're as a society, we're kind of just accepting those costs. And right now the premium is associated with doing the right thing, and that should be kind of the inverse. So I think that's probably something we all as a group believe in, and I think that's why we model these things, so that we understand the carbon cost. And it's 100% true. Like, without a financial penalty or cost associated with high carbon materials, we will still see those be selected. But we're starting to see, maybe not a direct answer to this question, but the question that comes up time and time again is, why should we switch to all electric heating? Isn't it going to be more expensive than gas heating? And right now we often see that it's the opposite, and that electric heating with an efficient heat pump is actually a more cost-effective option, and probably will continue to be more cost-effective. So I think these things are changing a little bit, but personally, I'd say I definitely agree. We should be adding a true financial cost to some of the decisions that we're making, and we'd see very different outcomes.
I'll add a note to that too. For both residential and commercial, I think there's other benefits to retrofitting as well. Like we are, if you can see in the background, we are currently renovating part of our house. The benefit of us not completely tearing it down, because we're kind of doing every room and every floor one by one, is that we can still live in the house, right? So also, if you're looking at commercial buildings, If you're just doing the commercial portion on the bottom, if it has a residential on the top, you can still allow people to live there. That'll give you some passive income. So it's not all black and white as in like, let's just tear it down completely. Retrofits can be done in a very flexible way, and you can pay the stages over time as well.
I think there's been really interesting, there's the whole carrot and stick thing. What have been the carrots for being more energy efficient, incentives for, you know, proper demolition, etc. And then I think what you're talking about is that cost penalty, in terms of a stick in you know, when you're demolishing a building on how it's or avoiding demolition. And so I think in Vancouver now, it's just, if it gets into the codes or into the local green standards, then it's just going to be a requirement. And it's going that way. So there are jurisdictions now that have requirements in terms of demolition, avoiding demolition, doing the embodied carbon calculations. I'm not exactly sure how it works in terms of existing buildings yet, but it's coming. And so that's good news.
All right. Next up, we have Ellie Bourget. I'm looking up Gutex products and the R values seem pretty low. Am I misreading this? How do you meet and exceed basic OBC requirements with wood fiber insulation? I think, Joel, I saw you typing. Do you have an answer ready?
Yeah, I mean, I think this is, I mean, these are all good questions. So in my experience, Gutex is comparable to things like cellulose, things like mineral wool. And so I'm not sure what information specifically you're looking at, but I think this is where the importance of making these materials more mainstream and more readily available, and us being more familiar with them becomes really the important key piece. Because in one of the projects that I think I shared very briefly, we directly replaced mineral wool with wood fiber. So it was a direct replacement for a product that everyone was familiar with to a new product that had generally the same installation procedures, performance requirements, et cetera. And so, yeah, maybe that's.
Yeah, so mineral wool R4 per inch and wood fiber also R4 per inch. So we're not going to get the XPS R6s per inch. It's not happening, but it's not like, none of us really look at XPS anymore. We would like, no.
And,
so
and it's all part of a system as well too, right? Sorry to cut you off, Carolyn, but just like it's all these different products sort of working together, you know, the wood fiber plus the cellulose plus the different pieces that come together to create the system that meets and exceeds those codes. Sorry.
Yeah, so no problem getting a code house, which quite honestly, the insulation levels of current code houses, not too bad. If you have to make a decision between upping the insulation or, you know, better windows like Kim had said, or, you know, some other measure, you know, we'd like a bit more insulation, but not too much. And so you can totally switch fiberglass bat for cellulose, and you can get your continuous insulation on the outside with wood fiber. Again, a bit tricky to get still, but hopefully that will change.
All right, we have 2 more questions. Let's see if we can get them in. First one is, I must admit to being obsessed with scaling this up. Once carbon has been generated, how can we avoid losing that? See some eyebrow raises?
I mean, if it's generated through construction, then it would be thinking about the whole life cycle of products and buildings. And again, going back to the idea of building a more circular economy and building a more circular, construction is very linear. We you know, extract raw materials, we build things, and then they end up in a landfill. That's the current kind of pathway that buildings take. And if we can instead think about taking buildings apart, and we think about that when we're designing them, there are going to be challenges today if we try and take apart existing buildings because they weren't designed with that in mind. And when we use products like spray foam, it's, you know, near impossible to try and pry these materials apart. So it's really important that we think about the life of a building beyond its current life and the life of those materials beyond their current use. That's probably the way I'd answer that.
Mm-hmm. Yeah, I think you're bang on there, Joel. I think we have to look at buildings like we look at Lego and like we look at Meccano sets and stuff like that. It's like you build a thing, taking us back to our childhoods. You build a thing and then you take the thing apart and you build something else with the same things. But, you know, the material stays, then the embodied carbon within the material stays with the material.
All right. We have 1 minute left. That's the last one isn't really a question, so I'll read it quickly. Embodied carbon versus upfront carbon in designing guide to building a house. I can answer it really quickly, I think. Just to be clear, embodied carbon and upfront carbon are pretty much the same thing. So it's all the materials and transport and work you're putting into while building the house. If you're talking about embodied carbon versus the operational carbon, right? Like that's the balance that we're really looking for. And that's where you want to look at programs that can help you with that to make sure you're striving, you're achieving that balance between those two. Hope I understood that correctly. Did anyone understand it differently?
No, I understood it the same way. And really, as you say, Kim, what we want is the lowest possible embodied carbon and the lowest possible operational carbon. No, not one with the other. We got to look at both.
Yeah. And best to look at it over a period of, you know, 30 years, because that's usually when materials start to deteriorate. So that's when, or at least we can't guarantee that they last past that. All right. And it's 12:30. We did it.
Excellent, great. Thank you so much, Kim, Joel, Brad, Duncan, Carolyn, and Paul for a great webinar and discussion today. Thanks also everyone who attended. And as we conclude this webinar, I would like to draw your attention to some announcements. The next webinar takes place on November the 28th with its title, A Specification-Based Approach to Embodied Carbon, Discoveries, Challenges, and Opportunities. As mentioned, the OAA will report your participation in this webinar to your OAA transcript. Therefore, there is no need for individual reporting on your part. We kindly ask for your patience as we process and confirm your hours. Additionally, all attendees will soon receive the presentation file via email along with the link to submit your feedback. Once again, thank you all very much for your attendance and have a productive and pleasant remainder of your day. Thanks again. Bye-bye.